Okay, and this is 7.5. So when you're multiplying a binomial times itself, you got to remember to do FOIL. It means you take that binomial times itself. There shouldn't be a square there, sorry. And you have to go FOIL. You got to remember all of that, right? You'll see that in this lesson. It'll make a what? What's that answer called? What kind of polynomial is the answer? No, that's a binomial. It's what? It's a trinomial answer. It'll be a trinomial. And then here is a trinomial. Just remember that this trinomial can be factored to x plus 4 squared. What kind of trinomial is this one? It's a perfect square trinomial. It comes from a binomial times itself. The same binomial times itself, so a binomial squared. The 4 times the 4 will give you the 16, and then the outer and the inner on this deal would be 4x and 4x to give you that 8x. All right, let's mental math. We can evaluate. Evaluate means just plug a number in. Let's just do this with mental math. This number 3 right here. If I was to put a 4 there, 4 times 10 is minus 4. So this would simplify to 6. Y'all agree? Let's mental math this one. Put a 4 here. Is cube root of 8 is 2. Y'all good with that? You will use the putting a number in thing in this lesson. All right, 4 right here. This is 4 times 6, 24, plus 192. I think it's 216. The cube root of 216 is 6. 4 times 2 is, cube root of 8 is 2. So this whole thing down here just turns into 6 minus 2 is 4. Okay with that? These kind of skills will be the skills you will use in this lesson. All right, turn the page. So again, we're going to work with a radical equation now. And it is an equation that has a variable in a radicand or a variable with a fractional exponent. Those are the two things we're going to be working with. Variables in the radicand or a variable with a fractional exponent. So, some more there, but real simple. If you look at example 1, example 2, this is a square root equation because the variable is the radicand. See that? This is part of this lesson. This is new stuff you haven't done in algebra 4. Over here, this is not a square root equation because the variable is not a radicand. To solve this one, I would just subtract square root of 3 from both sides, right? X would equal 10 minus the square root of 3, whatever that is. Nothing new there. Over here, because the unknown is in the radical, there is some new step. We'll walk through. And then, so there's that option. We know that if to solve a radical equation, isolate the radical on both sides of the equation, and then raise both sides of the equation to that power. So if you have the unknown right here, the unknown is the x raised to the square or some root of that x. To solve it, once it's isolated, this is isolated, you raise that side to whatever that index is. Raise both sides to that same power, and you'll isolate your x. So all that, I know that might be kind of confusing. An example. This right here started as the cube root of x equals 6. So the cube root of something equals 6. How do I get that x out of that radical sign? This property right here says cube. If it's the cube root of x, cube that side and cube this side. And just like we were doing like James, you had this a minute ago, 6 to the third power is 216, isn't it? Or in other words, the cube root of 216 is 6, isn't it? Yes, yes. If it was square root of something equals 6, you would square both sides. Very good. Mathematically, Matthew helps us here understand this. If you are cubing both sides, why does it make it just x right here? Yes, the cube root of x is the same thing as x to the 1/3. Inverse property, 1/3 times 3 is 1. That's right. So that's why you raise it to that power. So the inverse property will help you isolate the x. Okay, let's turn the page. I want to show you some step-by-step here. There's nothing, it's all in your book, but just kind of walk through this a little bit. The rule says I should make the part that's the radical by itself, so I probably want to bring the 2 over here. If I do that, that's the first step, isolate the radical. I got 4 over here because I've subtracted 2. Then, because now the radical is by itself, this is the square root of this value, probably going to square both sides. Y'all good with that? Yep, square both sides. This side, the radical sign goes away, and this side becomes 16. And then this now looks a lot more like an Algebra 1, an 8th grade, or 7th grade equation. All right? Add the 2, divide the 3, we get 6, and you can check it. You put it right back up in there to make sure it works. 6 times 3 is 18, minus 2 is 16. Like you see, square root of 16 is 4, and 4 plus 2 does make 6. So it checks. So the only thing new is isolate the radical part, then you might have to raise both sides to some power. Well, it'll get a little more tricky. It'll get a little more tricky than that. Here's another one. I need to isolate the part. This is a rational exponent. So what could I do to start? I could get that 2 off that side, couldn't I? Bring the 2 over here. I got that as 25. Now I would raise both sides to something. What would I raise both sides to? 3 halves, yes. This over here would simplify, and this is taking the square root of 25 and then raising it to the 3rd power. Now the square root of 25 could be both 5 or negative 5. So then when I raise it, to the 3rd power, I could end up with a positive 125, or I could end up with a negative 125 on this one. Add the 2, and I would get 127 or a negative 123. Check them both and check it out. They both check out perfectly. Shows that. Okay, turn the page. I got one more example to show you. There will be a couple in your work that looks like this one. There is a place or two in your homework that you'll do something a little more like this. What would be the first thing I need to do? Subtract 5, or very good. But notice, if I've got x minus 5 over here, if I square that side, what word did we talk about at the beginning we will use? It will turn into a trinomial. What word will I use to multiply? FOIL, yep. So, because that is the square root of x minus 3, I will square both sides, so I do have to use FOIL here. Using FOIL, I can't forget first, outer, inner, last. I get this whole trinomial. Hey, what is this thing called? Remember we spent a whole chapter and a half working with quadratics, where the parabola crosses the x-axis. We used our calculators and did polytools, right? Where we could find the solutions. Or we could factor it and set those factors equal to 0. So I'm going to bring everything to one side. I'm going to add the 3. That'll be a 28. I'll subtract the x. So we got everything over here. We got a negative 11x. We got a 28. Now, right here at this point, I could put it into my calculator, do polytools. If I think I can factor it, I'll factor it. If I don't think I can factor it, I'll use polytools and find those roots. Find those 2 possible solutions, because remember, a parabola could cross twice. And this one factors actually kind of easy. 7 and 4 make 28. And adding outers and inners combined to make negative 11. So you have potentially the options of 7 and 4. Set those equal to 0. X could equal 4 and x could equal 7. You check them both. 4 does not work out. 4 minus 3, 1. Square root of 1 is 1. Plus 5 is not 4. So one of those do not work. You'll have that happen a couple times in your work where you can get 2 answers and sometimes one of them does not work. Okay. I'm gonna pause right there.